Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 14, 2025, just yesterday. The big result is that this paper trains end-to-end pixel space generators to top-tier quality and speed, with the diffusion model hitting FID 2.04 on ImageNet 256 and 2.35 on ImageNet 512, using 75 function evaluations, and a consistency model reaching FID 8.82 in a single step. The paper is titled Advancing End-to-End Pixel Space Generative Modeling via Self-Supervised Pretraining. And as we'll see later, the implications for model training are quite significant. In short, a two-stage self-supervised pre-training of an encoder, followed by end-to-end fine-tuning with a fresh decoder, closes the pixel versus latent gap while avoiding external VAE or diffusion checkpoints and keeping compute efficient. Also, the authors shared the GitHub repo. Inside, you'll find the official implementation placeholder, with a concise README outlining the two-stage training, reported ImageNet FIDs, and sample figure assets. The code itself is still being cleaned up, so training scripts and usage instructions will be released there soon. Alright, Figure 1 shows that the method delivers high image quality with lower inference compute compared to prior pixel models. The left scatter plots Fréchet inception distance, which measures realism and diversity with lower being better, against log-scaled gigafloating point operations. Our point sits near the top left, so quality is strong, while cost stays modest. The right panel presents diverse samples, which look sharp and well-structured across animals, objects, and scenes. Alright, Figure 2 shows the training pipeline at a glance. The left panel illustrates 3 pre-training branches that learn semantics with a contrastive loss and enforce representation consistency, which means aligning features of adjacent noisy points along the same trajectory, the class token and a time token condition each encoder. On the right, fine-tuning stacks the trained encoder with a fresh decoder, so the system learns end-to-end pixel synthesis without external models. So, Table 1 compares system-level ImageNet 256 results under classifier-free guidance. The table shows that the EPG pixel model leads its pixel peers with FID about 2.0 and strong inception score, while using 75 denoising steps, where number of function evaluations means the count of function calls per sample. The upper block lists latent-space methods that edge out quality but depend on a VAE. The lower block highlights pixel space baselines that EPG surpasses in both quality and efficiency. While Table 2 extends the comparison to ImageNet 512 and shows that the pixel model holds its lead under classifier-free guidance. The key point is that EPG with 32 patches reaches 2.35 FID, which signals high realism at this resolution. Sampling stays efficient with 75 number of function evaluations, so generation is fast. Training remains practical because the reported parameter count and compute look modest relative to latent baselines. So the big takeaways are clear. Self-supervised encoder pre-training plus end-to-end fine-tuning makes pixel space diffusion and consistency models both strong and efficient, and the approach delivers the first practical high-resolution consistency model directly in pixels. The broader implication is a VAE-free path to fast, scalable image generation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.